Hello, 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 everybody. Root Beer here, and today we're going to take a look at question number 22 on the 2003 Cayley paper. In the diagram, triangle ABC is isosceles with AB equal to AC. Okay. And BC is equal to 30 centimeters. So we've got a length. We don't know what the lengths of AB and AC are, but we know whatever they are, it's going to be the same length. Square EFGH, which has side length of 12 centimeters, is inscribed in ABC. So it just touches, and E and F are on AB and AC, and all these lengths on the square are going to be 12. The area of triangle AEF in centimeters is... Oh, okay. Well, let's redraw our picture, so that way we have something to mark up, something to add notation or anything else, draw brand new lines, whatever we see fit. So we'll draw our picture, try and make this as isosceles as I can. Oh, that's not great. In fact, we're going to restart that one. That's a little better. So we have A up here, we have BC, and I know that that is 30. And then we have this square in here, which on mine looks a little more like a rectangle, but as long as the picture makes sense to you and you understand what's going on, that's fine. So we're even going to label these as 12 and 12 and 12 and 12 just to make sure. Was it G here? Did they go? Yeah. Usually they go clockwise in their lettering scheme, which is a good practice to go through. So EF, I knew G would have to be down here because no way G would jump over here. Okay. Looks like they went clockwise for lettering the corners of the square, but counterclockwise for the triangle. Right? Yeah. Interesting, but ultimately irrelevant. Okay. So, what can we do here? Well, we're asked for the area. Already I can see right in the middle this square, 12 times 12, 144. We've got that as our area. So area is definitely going to be bigger than that because we've got all these triangles here. What can we do about these triangles? Well, it's isosceles, so I think, first of all, I'm going to make a note that there are some right angles here. And a right angle with a side of 12 here, that's mighty suspicious. I start thinking of things like 5, 12, 13 triangles, or 9, 12, 15, that's another good one. What else can we do here? Since it's isosceles, the angles at B and C are going to be the same. And then we're going to get 90 minus the angle at C here, and 90 minus the angle at C here. So we're going to get these two purple angles up here as well, because green plus blue plus purple has to add up to 180 degrees. So it looks like AEF is isosceles, and it's a similar triangle as well. We'll add in this angle just for fun. So AEF is a smaller triangle. What else can we do here? Well, it's isosceles, so one thing we can do is we can, there's the red, we can split it right down the middle. If I drop a perpendicular, it's going to split this into 2 equal halves, so we're going to get 15 on one side and 15 on the other side. Does that help me at all? It's also going to split this 12 into 6 and 6. And that leaves 9 here and 9 here. And, oh, we've got a 9, 12, and it'll be a 15 triangle. We can see this by Pythagoras. 9 squared plus 12 squared is equal to 15 squared. So we're going to get 15s over here. That's a 15, that's a 15. Okay, does that help us in any other way? Well, we get more right angles here, which means that this orange angle is actually just two green angles. And we get 6's here. So we actually get similar triangles here. Let's call this point of intersection I and this point of intersection J. So triangle AFI is similar to triangle FCG. Okay. Because they're similar, the side lengths will have a common ratio. Well, we already know one of these side lengths is 6 and the corresponding side length is 9. All we really need to do are get heights, because we have a bunch of right angle triangles, and we need to remember we're looking for areas. So since they're similar triangles, that means ratios have, or the sides, similar sides have similar ratios. So Fi over Cg, and that's equal to Ia over GF. Now, IF, or Fi, is 6, and CG is 9. So we get a ratio here of 2 over 3. But FG, or GF, is 12, so IA, which is the height of those smaller triangles, so 2/3 is IA over 12, and so this tells us, we can quickly rearrange and see IA is 8. Is 8. Ugh. Let's redraw our picture, just free of some clutter. So we have the big square in the middle, and we've got 12s, right angles. We have this other right angle here, just splitting it in half. 6, 6, 8. And we've got 9 here, 9 here, 12 here. Okay, we can add in more if we wanted to. For example, by Pythagoras is going to be 10, this will be 15, but we don't need those. We have to keep our eye on the prize, and we're asked for area. Okay. Well, the area of the square is 12 times 12, which is 144. The area of this triangle over here, 12 times 9, base times height divided by 2, that's going to be 54. Same with this one over here. 12 times 9 is 108, divided by 2 is 54. And how about these ones up here? Well, 1/2 base times height. 6 is the base, 8 is the height. 6 times 8 is 48, divided by 2, 24, 24. So ultimately the area is 24 plus 24 plus 54 plus 144 plus 54. And that's 48 plus 144 plus 108. The 4 and the 14, that would be 184. Left an 8 left over. 8 plus 8 is 16. So we got 184 plus 116. 84 plus 16, that's 100. So we should get an answer of 300. Okay. Another way to see that, we have this height 8 here. Along with this height 12, we get a full height of 20, and we knew the base was 30. So 30 times 20 all over 2, base times height, that's 600 over 2. 300, that's another way you could do it. The 300, either way we slice it, that's our answer. Probably a couple other ways we could have gotten an answer of 300. Oh, whoa. My mistake. We don't want the big one. We want just the small one, AEF. Okay. This is why it's very important to read question. I'm going after the wrong thing here. So we didn't need to work out those smaller areas. We just need AEF. Well, here's A, here's E, here's F. Well, that's just 24. Plus 24, which is 48, and that should be our answer. 48, there it is, D. So I do apologize for that. I must remember in the future to read these even more carefully than I tried to already, but D. D is going to be our answer. And fortunately, we did enough work that we didn't have to go back from scratch there. So that's nice. We can pat ourselves on the back at least for that. And we prepare for question number 23. And I'll take a look at that one next time. So I'll see you guys then.